light-years or 64 trillion miles away, so close in the grand scheme of cosmic things. This is important, as these 3 exoplanets around the GJ887 star provide one of the best possibilities for study in the search for life outside our solar system. GJ887 is classed as a red dwarf, which tend to be larger and more reactive than yellow dwarfs like our Sun. However, this red dwarf is relatively quiet and tame compared to others of its class. It produces less solar flares, so that the light, heat, and radiation it emits are more constant than erratic. The 2 confirmed super-Earths may be a little too close, and as such too hot to contain liquid water. However, the third is within the narrow band of distance dubbed the habitable zone. A close cousin. The exoplanet GJ357d is around twice the size of Earth, but also has 6 times its mass. It too falls in the habitable zone and likely has a dense atmosphere that could be able to trap enough heat close to the planet to allow liquid water to form on its surface. It orbits a star that is a third of the size of our own and around 40% closer. A year is 55.7 days, and the distance is around a fifth of the Earth from our Sun, meaning it's very likely to have Earth-like conditions. The best super-Earth contender. Over towards the center of the Milky Way galaxy, 1,200 light-years from Earth, in the constellation Lyra sits Kepler-62f. It's a curious exoplanet that is being dubbed a 1 in a million super-Earth. Its mass is 1.4 times more than that of Earth, small enough to have a rocky composition with a molten core. Its brown dwarf star is much smaller and cooler than our Sun, and although the exoplanet is in an orbit the distance of Venus from their Sun, the distance relative to the heat of their Sun is similar to Earth. A year lasts around 267 days, and temperature conditions could be remarkably like that of our climate. So far, it is without a doubt the closest exoplanet to Earth that we've found by a huge margin. Its nearest neighbor, Kepler-62e, is another Goldilocks planet 1.6 times the size of Earth that also sits well within the habitable zone of that system. Modeling the 2 planets based on the data recorded points to both being engulfed in water, having great seas and oceans just like our own. Atmospheric gas could lead to trapping the water vapor, forming clouds, and causing precipitation. With life evolving from water, they are great candidates for the best chance of finding life outside our solar system, if we could only get there. The gravity is less than Earth's, and human beings would have no trouble walking around on its surface. Though the atmospheric composition of Kepler-62e could potentially support respiration, Kepler-62f is totally out of the question. Spacesuits with breathing apparatuses would definitely be needed. Life on these worlds would have to be totally aquatic, which begs the question, would an intelligent civilization on these planets be anything like ours? With no exposed land, there would be no dry vegetation, which means no fires to cook food with, to melt metals, or to generate warmth. As the planet's surface is well below sea level, harvesting resources and mining materials from the solid ground would be very difficult. On Kepler-62f, if the planet's rotation is not locked with its orbit and the amount of carbon dioxide in the atmosphere sits between 3 and 5 bars, a stable ecosystem is entirely possible.
No distinct wings, no distinct tail, no distinct exhaust. It seemed like they were aware of our presence because they would actively move around us.
It's easy to refute claims of UFO sightings as the product of overactive imaginations, or made-up stories by people in tinfoil hats living in their mother's basement trying to push their misplaced beliefs and conspiracy theorist agenda on the world. But what about when trained pilots, or even better, astronauts, are the ones making the reports? Number 10. Declassification. In September of last year, the U.S. Navy released a statement formally acknowledging that unidentified flying objects do exist, and that the footage causing a buzz around the world is legitimate and not faked. This is a quantum leap from the deny and classify everything stance held by government agencies for well over half a century. The motives for the confirmation of sightings by Navy pilots was to remove the stigma associated with using the term UFO when describing phenomena that may be hazardous in nature during a flight. The Navy was also careful to tiptoe around the elephant in the room, and purposely made no comment or assumptions about working theories on what the objects in the videos may or may not be. This is a confirmation of just a tiny fraction of the classified footage the government has under lock and key. Number 9. Credible witnesses. Pilot Clarence Chiles and co-pilot John Whited report seeing what they described as a great double-deckered flying cigar back in 1948. They said it had an upper and lower row of windows, and there was a red glow above and in front of the aircraft. There is a recorded audio of the two discussing whether it could have been an Army test flight. It flew past the right side of their plane with a bright streak of light before making a sharp turn straight upwards. It shot flames out back and took off up into the clouds at phenomenal speed. The military shrugged it off as a meteor, despite one of the passengers also corroborated the story. Besides, shooting stars don't fall upwards. Number 8. Gone fishing. Leroy Chiao was commander of the International Space Station for a little over half a year in 2005. It's safe to say that those who make up stories don't receive such lofty appointments. He was installing navigation antennas on the outside of the station when he noticed 5 strange lights flying past in an upside-down question mark formation. The ISS orbits the Earth at 17,000 miles per hour, and the official explanation is that he saw lights from fishing boats 230 miles below. There are 2 possibilities. Either those boats are equipped with the strongest floodlights known to man, with each vessel moving in perfect synchronized unison and powered by an impossibly fast engine, or the lights weren't boats at all. Chiao himself remains skeptical and doesn't believe the Earth has been visited by ETs, but doesn't deny what he saw. Number 7. Close encounter. Lieutenant George F. Gorman claims to have seen a 27-minute game of cat and mouse with a UFO in the airspace above Fargo, North Dakota in 1948. He was approaching the runway in his P-51 fighter when he saw something 500 feet below him. He quickly radioed the tower, who confirmed that there were no other craft in the immediate area. He informed them that he would break away from his landing and investigate. He got within 1,000 yards of the object and later reported that it was 8 inches in diameter, a completely round shape with clearly defined boundaries and a blinking light. As he got close, the blinking stopped and became steady, leading him to believe a collision with the tower was imminent. He banked sharply to the left as the object went straight up, where he lost sight of it. Gorman maintains there was an intelligent thought guiding the movements of the craft. 6. Sworn to secrecy. Major Gordon Cooper had his fair share of UFO encounters. The most famous one was back in 1963 during a 22-day orbit around the world in a Mercury 2 capsule. A listening station in Perth, Australia received a transmission from Cooper where he reported seeing a green glowing object ahead of him that was closing in fast. The scary thing is that object was picked up from the ground by the station's radar, confirming the outlandish claim. NBC News covered the story as it broke, but when Cooper finally returned back to Earth after his mission, NASA forbade him to speak about it. Years later, he would cement his claims by saying that he believes ETs had visited from other planets, and that he saw many different sizes of UFOs flying in fighter formation moving from the east of Europe to the west. Number 5. Northern Lights. In 1951, U.S. Naval Lieutenant Graham Bethune was flying over Newfoundland, Canada, when he spotted a massive floating object. He estimated that it had to have been 300 feet in diameter and that his aircraft was on a collision course. It started off as a glow of light 1,500 feet above the water level of the horizon. He and his co-pilot observed the object for 5 minutes as they approached, then alerted the other crew members. The faint glow abruptly changed, with a multitude of colors pulsating from its center. The UFO inexplicably reversed its course and sped away at triple its approach speed off over the horizon. The aurora borealis, or green illumination sometimes seen in the northern night sky. The atmospheric phenomenon is sometimes used to explain UFO sightings, but in this case, ground radar confirmed that the plane came within 5 miles of the unknown object. Number 4. Witnessed by thousands. How do you explain a UFO when it's seen by not only the pilot, but the townspeople below? A Turkish Airlines flight was en route to Istanbul in 2016 when they experienced a mysterious green light flashing over their plane as an object passed 2,000 feet overhead. The state airport authority denied seeing anything to corroborate the story on its radar, suggesting it was a green laser pointed up from below and illuminated by cloud cover. The pilot and co-pilot testified about what they saw and were steadfast in their commitment to the story. They were adamant it was a light shone down from above. Thousands of people living nearby also reported the strange green lights. Number 3. It goes both ways. Not one, but two experienced pilots flying separate planes traveling in completely opposite directions claimed to have seen a UFO pass by as they flew over New Mexico in 2018. The area is not far from the infamous town of Roswell, where it's claimed an alien craft crash-landed in 1947. After one pilot reported his brush with the UFO to the radio control tower, the air traffic controller contacted the other pilot nearby to warn him. He openly mocks the idea that anything will be passing over him. But just minutes later, he reports seeing the object 3,000 feet overhead, confirming it was a UFO and not a weather balloon. Both events took place within 100 miles of Luke Air Force Base, though they confirmed there were no test flights taking place at the time. Number 2. This is your captain speaking. On a clear evening in 1989 with a big, bright full moon, pilot Andrew Danziger was in charge of a routine flight leaving Kansas City. Not long after takeoff, he saw a round white disc off to his right, flying parallel to his passenger jet and matching their speed and course. His co-pilot also noticed the UFO, which appeared like the moon seen through a veil of light fog. Neither had seen anything like it despite flying together over many years and seeing all kinds of things up in the sky. Number 1. Seeing is believing. Navy pilots were tasked with tracking a series of UFOs in the Pacific Ocean over the course of several weeks in 2004 as part of a Pentagon program. The objects were said to appear out of nowhere at 80,000 feet before suddenly diving down towards the sea before stopping and hovering at 20,000 feet. From there, they would either dip below out of radar or rapidly rise up again and out of sight. At one point, Jet Pilot Lieutenants David Fravor and Jim Slight were ordered to investigate closer and attempt to follow the craft. One white-colored UFO hovered 50 feet above the water, sending waves across the sea surface around it. It began to jump around erratically, staying over the general area but not moving away in any particular direction. In another encounter, infrared sensors locked onto a target before it accelerated so fast out of frame that the instruments failed to relocate it. The UFO was flying against the wind and slowly rotates before it speeds out of sight. How the universe began, how it's going to end, and how it works. All questions that science struggles to provide a hard and fast answer for.
Any kind of black hole that could pass through the solar system would be pulling on all the planets harder than the sun does.
The violence of this is hard to imagine. Two planets coming together.
Of stars as
After an impact of that scale, the entire surface of the Earth is literally liquefied.
Theories are ever changing, and as we strive to unlock the secrets of the universe, we're met with more questions than answers. So what are some less widely accepted theories about the universe that just make sense? Welcome to Factnominal. Today, we're separating fact, fiction, and conspiracy theory in universe theories that just make sense. Number 10. Brain world. No, we don't mean brain as in the thing between your ears. We're talking about the clash of membranes. And although it sounds like a bizarre concept, it actually has some merit. The brain world concept pictures our universe as a membrane floating in a higher dimensional space, repeatedly smashing into a neighboring membrane universe. Though gravity can reach out between membranes, our existence is confined to the 3 dimensions of our own universe. According to this idea, the Big Bang could have been caused by one of these impacts between 2 membranes. More to the point, if it's happened once, it's likely to happen again, pointing to the possibility that there are multiple and never-ending Big Bang-level events. An immortal cosmos caught in an infinite cycle. Number 9. The Big Splat. In the very distant future, the rapid expansion of the universe will accelerate to the point where galaxies will move so far adrift from each other that the light from Galaxy A will be unable to reach Galaxy B. The expansion rate would exceed the speed light travels. Eventually, there will be no more raw materials for the birth of new stars, and those that already exist will burn out and die, creating a universe devoid of light and heat. It may sound all gloom and doom, but it doesn't need to be. The beginning of a new universe is just a smash between brains. Over time, 2 empty and spent universe membranes could collide with each other and generate enough energy to stimulate another Big Bang, subsequent rapid expansion, and birth of a new universe. It's referred to in scientific journals as ekpyrotic theory, or more affectionately, the Big Splat. Number 8. The holographic universe. You've heard of living inside a simulation, but how about a holographic universe? Ask anyone what the universe is made of, and they will give you the same answer: matter and energy. But what about information? A ribosome in a human cell is supplied with amino acid building blocks and energy from the mitochondria, but it can't make anything without the blueprint from the cell nucleus. This holographic principle works in the same way when describing the universe. It's a combination of string theory and the unique property of quantum gravity that can describe the volume of space from encoded data on the lower dimensional boundary of the region. Think of space like a hologram, a two-dimensional picture that has the data to create a three-dimensional image. It's a testable theory and is a pattern consistent with cosmic microwave background radiation left over from the Big Bang. Number 7. The steady-state universe. It's widely accepted that the Big Bang was a singularity, a point of near-infinite mass and density from which all the matter and energy in the universe originated, before it rapidly expanded outwards from the central point. Nothing will ever be as dense as the Big Bang singularity, and over time, the density of the universe decreases as it expands through space. But what if there were a way for density to remain constant in this ever-expanding universe? The steady-state universe theory describes the continuous creation of matter as possible at a rate of 3 hydrogen atoms per cubic meter every million years. In theory, the universe has no beginning, no end, and no finite age. Einstein once considered a steady-state model for the universe, but abandoned the idea. It fell out of favor as the commonly accepted theory with the discovery of cosmic microwave background radiation. Number 6. The multiverse. The current working Big Bang model predicted the existence of cosmic microwave background radiation, but it struggles to explain its uniformity. A theorized period of early superfast expansion was needed for it to work, otherwise known as inflation. When our universe ended this inflationary period, it may have been a single small bubble sitting in the vast sea of space. It's possible that other little universe bubbles were also floating in this void. In other words, a multiverse of universes. As expansion slowed following inflation, the laws of physics in our universe stabilized. But it's entirely possible that in other universes, our laws don't apply. Their force of gravity may be stronger, they may have a faster speed of light. There is a cold spot in the cosmic microwave background radiation that could be evidence of a collision with a neighboring universe within the multiverse. Number 5. The evolving universe. The gravity of a black hole compresses matter into a single focal point, a place that exists outside of the dimensions of time, space, and reality. What if this dense focal point bounced back and made a new baby universe? The offspring made by black holes may have differing laws of physics from their parent universe and would in a way evolve from them. If, and that's if, we live in a typical universe and have physical laws of physics and mathematical constants that favor production of black holes, then perhaps ours would be one of the more dominant ones in the multiverse. By the same theory, our universe would exist within the black hole of another. Number 4. The Goldilocks universe. What constitutes a universe that has the ability to support life? Certainly ours does, or we wouldn't be here to observe it. The fact that we exist, that we know we exist in this particular universe, strongly indicates that we can assume our universe has the correct parameters for life to not only exist, but thrive. By mildly modifying some universal constants, the formation of stars and matter becomes an impossibility. The universe collapses within the blink of an eye. String theory hints at the fact that the universe has almost infinite number of different properties and laws that could combine in any way. Inflation points to the possibility of infinite universes, so theoretically ours could be the only one, or one of very few, with the ability to sustain matter and therefore life. Everything in just the right amounts. Number 3. The ghost condensate. Something unknown is ripping apart space-time. Something unknown is holding galaxies together. Something unknown made the cosmos go bang at the beginning of time. These unknowns are dark energy, dark matter, and inflation. But what if they are all the same thing? A single change to Einstein's law of gravity and general relativity could account for this trio of unexplained and undetectable phenomena. The result is a weird, omnipresent, all-pervading fluid of massless particles called the ghost condensate. These exhibit repulsive gravity, like an elastic band that stores more and more energy as it stretches further apart. If you think of it this way, it kind of does explain how dark energy pushes space apart, how dark matter holds galaxies together, and the rapid inflation immediately after the Big Bang. Number 2. Superfluid space-time. Everything in space spins in relation to each other's gravity: stars, planets, galaxies, and clusters. Yet research points to the fact that the universe itself is not rotating. But why? Maybe space-time flows like an incredibly smooth and free-flowing superfluid. It would resolve the inherent contradictions between two popular and opposing theories. Particles and photons would travel through space-time like waves in an ocean, according to the laws of fluid mechanics and condensed matter physics, losing energy over time as they travel through the superfluid medium. Possibly, photons of different energies travel at different speeds and could even dissipate over time, proving that general relativity doesn't account for all circumstances and that the speed of light is not a universal constant. This would mean matter is just debris adrift in the vast ocean of space. Number 1. Mond gravity. Dark matter may not be matter at all. It could just be an unobserved behavior of gravity. Modified Newtonian dynamics, or MOND, pronounced MOND, suggests that galaxies are not held together by phantom, undetectable stuff at all. That there is a perfectly logical explanation for why the velocities of stars and galaxies are observed to be larger than expected based on regular Newtonian mechanics. Maybe the answer's been found by adding a minimum value for acceleration. Perhaps gravity doesn't fade away as quickly as current theories dictate, and this version of gravity that is stronger and more longer-lasting could fill the role thought occupied by dark matter. This alternate form of gravity could be the binding force of galaxies and clusters. The Mond theory is consistent and works within general relativity and has accurately predicted certain phenomena in the universe, stating that the observable universe makes up just 5% of the total stuff contained within it might be an assumption that's as wrong as it sounds. The Red Planet. Ever since we conquered the moon back in 1969, humanity has looked to the stars for the next big challenge. Our romanticism with Mars dates back millennia, and for a long time it's felt beyond our reach. But with international space communities and ambitious billionaires setting their sights on our solar neighbor, we could be closer to reaching the Red Planet than you think. Welcome to Fact Nominal. Today we'll be diving into humanity's next great space endeavor to our planetary neighbor and visiting Mars. We're closer than you think. How it all started. The first visitor to the surface of the Red Planet from Earth was a lander built by the Soviet Union in 1973. It was meant to land safely on the surface of Mars where it could make observations and conduct experiments. As it happened, the lander was destroyed on impact when it arrived over a year later in December 1974. In 1975, it was NASA's turn, successfully launching 2 landing craft, Viking 1 and Viking 2. The 2 craft touched down on the surface of Mars in 1976, where they conducted numerous tests and took photos of the alien landscape. While the Viking landers were only intended to operate for 30 days, the onboard radioisotope thermoelectric generators kept running for years. Viking Lander 1 made a final transmission to Earth November 11, 1982, 6 full years after landing successfully. Following the touchdown of the first landers in the 1970s, many other organizations have attempted similar missions to Mars. The European Space Agency launched its first lander in 2003, which was promptly lost upon arrival. A similarly unsuccessful mission was undertaken by Russia in 2011, which aimed to retrieve a sample of the Martian moon Phobos while also placing a Chinese probe in orbit. Communication and control was lost shortly after launch, with the rocket and probe being stranded in low Earth orbit before finally re-entering and disintegrating above the Pacific Ocean in 2012. As time has gone on and technologies improved, Mars missions have been successful and the craft better equipped. NASA's Curiosity rover and InSight lander were the most recent visitors to the Martian surface in 2012 and 2018, respectively. Both rovers have provided valuable information relating to habitability and the internal structure of Mars. In recent years, Mars exploration has shifted from unmanned missions to manned missions due to the competition between various organizations and companies, which has increased the pressure to get people to Mars first. Mars One intends to permanently send humans to Mars in 2031, while NASA plans to get people to Mars sometime in the 2030s. The United Arab Emirates also has set their eyes on Mars, with plans to build a human settlement on the red planet in the next 100 years. They're even currently building a Mars city in the desert with conditions similar to those on the red planet so that technology and building materials can be tested before being used for a Mars mission. The frontrunner for Mars exploration, however, is none other than Elon Musk's SpaceX, with the ambitious target of landing humans on the red planet in 2024. Before any company or organization is able to visit Mars, they will need to overcome many challenges, including getting to the red planet, providing shelter for explorers, and producing food and water in a hostile environment. Challenges. The first step in visiting Mars is figuring out how to cross the great expanse of empty space that separates us from the Martian soil we wish to inhabit. The first challenge is fuel. A massive amount of fuel is used just to leave Earth's atmosphere, leaving not much left over for the 6-month journey to Mars. To overcome this, SpaceX has envisioned the Starship rocket, a craft capable of taking off and waiting in orbit to be refueled by a second Starship launched simultaneously. Refueling the Starship rocket while in orbit means that a greater amount of equipment and resources can be carried on the half-year voyage. Arrival. As the Starship approaches Mars at the eye-watering speed of 16,800 miles per hour, it will begin to slow down due to air resistance from the thin Martian atmosphere. Unlike the carbon fiber composite heat shields of previous landers, Starship's exterior is made of stainless steel, which counterintuitively can withstand and dissipate heat much more effectively. Thrusters on the underside of the Starship allow the rocket to slow its descent enough to safely land on the Martian surface. After a long journey aboard the Starship, the first humans will walk the surface of Mars, where they will be met with a hostile atmosphere. The air on Mars is much thinner than Earth's and mostly composed of carbon dioxide, as well as unfiltered radiation from the sun that's a threat to both humans and the plants they hope to eat. Don't let the color of the red planet fool you. It may look warm, but temperatures can drop to lows of -195 degrees Fahrenheit. Shelter. If the first humans hope to survive in this inhospitable place, they will need to build shelters that are able to combat the chilly temperatures of Mars. Elon Musk has suggested that the first humans on Mars would live in glass domes. These would need to have some type of temperature control which would maintain a constant temperature that humans would be able to survive in. The pressure of the Martian atmosphere is less than 1% that on Earth, which is low enough for gases in the human blood to instantly turn into bubbles, killing any unprotected explorer almost instantly. For humans to survive on the Martian surface, the habitats will need to have pressure control, which maintains a pressure far higher than what is normal for Mars's thin atmosphere. Due to this thin atmosphere, high levels of radiation from the sun reach the surface of the red planet. This not only increases rapid sunburn to anyone not in the shade, but also, too, the risk of cancer. It takes 6 inches or 15 centimeters of steel to shield against this much radiation. To ensure the humans traveling to Mars are protected from solar radiation, the domes used for habitats would have to be built using radiation-resistant materials such as heavy metals or metal alloys. Building out of metal would be impractical since it's heavy and would be difficult to transport from Earth in large quantities. Alternatively, the domes could be built underground. Although building human habitats underground would be a good solution to the radiation problem, it's far more difficult than building above ground. Fortunately for the next batch of explorers, the 2024 SpaceX mission to Mars is a return trip, meaning the astronauts will only be on the surface of Mars for a limited amount of time. Radiation exposure over short periods is much safer when compared to living in a permanent and unprotected habitat. The Martian atmosphere is 0.04% oxygen, which is nowhere near enough to allow humans to breathe. Luckily, NASA and MIT have developed equipment that's able to convert carbon dioxide, the main component of the Martian atmosphere, into oxygen. That is, until plants can take over the carbon scrubbing duties. When the construction of the habitats have been completed, the astronauts will need to turn their attention to other pressing matters, such as obtaining food and water from a dry planet with toxic soil. Water. Humans need to drink around 3 liters of water every day, and it's also required for growing plants used for food. Water is heavy, and transporting large quantities of it from Earth to Mars would not be realistic. Luckily for those heading to Mars, there are expansive lakes of ice beneath the Martian soil, meaning the astronauts will be able to get a refreshing drink after doing some digging. Much of this water is very salty, however, desalinization or distillation can be employed to purify the groundwater. Once adequate amounts of water have been found, the astronauts will be turning their attention to their stomachs. The astronauts will bring only small amounts of food to the red planet and will need to produce the majority of what they eat. This could be done using greenhouses with regulated temperature and pressure. The Martian atmosphere primarily consists of carbon dioxide, which is what plants need to undergo photosynthesis. What a happy coincidence! Sadly, the soil on Mars contains high levels of perchlorate ions, which are toxic to plants. The soil will need to be chemically changed to support plant growth. Once the shelters have been built and the issues of food and water have been dealt with, the first astronauts will be able to survive on the red planet. What's next? Numerous companies and organizations plan to eventually develop a self-sufficient colony on Mars that's able to sustain human life indefinitely. At the moment, humans will only be able to visit Mars if they're inside habitats or a spacesuit. But this could change through a terraforming process where we literally modify a planet's
Дайте на
ecosystem.
вашето кученце
Think of it as
здравословен
climate
старт в
change
живота.
on purpose.
Строял Калин
Elon
Папи.
Musk has recently proposed the use of nuclear weapons on the red planet, which will melt the ice caps and warm Mars. This process may also result in a thicker
Can I just
atmosphere
get
that's
one
able to
fucking
nurture life.
son of a bitch
While at the
motherfucking
moment,
game
the only
where
people
I
who
can
can hope to
use
visit Mars are trained
Mordekaiser
astronauts.
R
One
one
day, you
fucking
might
time.
be able to
I
visit our
don't
planetary
understand
neighbor,
how
either
every
permanently
game,
or just for
every
a brief
day,
visit.
I lock in Mordekaiser, I can't use my R ability.
Moons
Like,
are
just
some of the
remove it
most
from the
intriguing
fucking game.
objects in
It's
space,
unbelievable.
as they orbit planets larger than them by several times. Yet one question has always intrigued scientists about the nature of moons. Can moons have a moon of their own? Today, we'll be finding out. Most planets in our solar system, and even exoplanets in other star systems, have their own natural satellites, what we know as moons. As defined by the NASA and other expert astronomers, a moon is a celestial body that makes an orbit around a planet. Moon materials range from rocky material to icy bodies and mixtures of both. Earth's moon is made of rock, while Mars moons are the same material as rocky asteroids. Saturn's moons are mostly ice with rocky cores. Its largest moon, Titan, is predominantly rocky with an icy surface. The moons of Uranus and Neptune are largely icy. Pluto's binary companion, Charon, is mostly rocky with an icy covering. The exact makeup of its smaller moons, which were likely captured after a collision, is still being worked out by scientists. However, can any of these satellites have a moon of their own? Short answer: yes. However, that doesn't necessarily mean that a submoon or moon can easily survive in any kind of environment without any sort of help. In most cases, there's not enough space for a submoon to orbit another moon. That's sort of the reason why there aren't many submoons out there. The region of space around a satellite where a sub-satellite can exist is called the Hill sphere. Outside the Hill sphere, a sub-satellite would be lost from its orbit about the satellite. For example, let's analyze the already existing Sun-Earth-Moon system. Earth is a satellite of the Sun, and the Moon is a sub-satellite orbiting Earth. The Moon orbits the Earth because the Moon is about 380,000 kilometers from Earth, well within Earth's Hill sphere, which has a radius of 1.5 million kilometers. The Hill sphere is basically the space where the Earth's gravity is more important than the Sun's gravity on another object. If the Moon ended up outside Earth's Hill sphere, then the Moon would orbit the Sun instead of the Earth, similar to other planets, asteroids, and comets. Which is sort of fun when you think about it. Jupiter's Hill sphere has a radius of 0.36 astronomical unit. That's of course much bigger than the Earth's Hill sphere. And that's because Jupiter is several times more massive than the Earth, and also has a stronger gravitational pull. On top of that, it's further from the Sun than Earth. so the sun's gravity is weaker at Jupiter than at Earth. Tidal forces would pull the little moon towards the host planet and rip the mini-moon to pieces. For it to survive, it would have to be a small mini-moon, roughly 6 miles in diameter or less. It would also need to orbit a large moon with enough gravity to hold it in place. Most moons in our solar system would be unable to do that.
All right, guys.
Regarding the naming trend of submoons,
Let's take a run.
scientists use the term moon for referring to a submoon. Others prefer submoon or metamoon as the prefix of choice for the moon's moon. Can our moon have a moon? Well, yes, the moon could have a subsatellite with no problem. If we look at a system of the Earth, moon, and a subsatellite, the same idea as above applies. The moon has its own Hill sphere, with a radius of 60,000 kilometers, which is roughly 1/6 of the distance between the Earth and the moon. That's where the subsatellite could exist. Should an object lie outside the moon's Hill sphere, it would orbit the Earth instead of the moon. However, a subsatellite cannot indefinitely stay in orbit around the moon due to the tidal effect. The moon, like almost all other moons in the solar system, is in synchronous rotation around the Earth, meaning it shows the same face to Earth at all times, a side effect of the tidal forces between the Earth and moon. These are the same tidal forces that cause the high and low tides on Earth. And using this configuration, any kind of object within the Hill sphere of the moon will have a decaying orbit due to tides. The orbit of any subsatellite of the moon will shrink over time, and the distance between this subsatellite and the moon will get smaller and smaller until it crashes into the moon, or the lunar tide rips it apart. On another note, can a satellite, like an artificial one, be considered a submoon or eventually become one? Well, lunar orbiting satellites only orbited for a few years, which is a very short time in astronomical standards, where planetary or galactic movements can easily span millions of years. Man-made satellites can stay in orbit around the moon or any moon for the duration of a mission, because tidal effects require thousands or millions or more years, depending on the system, to cause the loss of a subsatellite. Because of this, we can leave a man-made satellite in stable orbit around a moon for a few years, using the spacecraft's rocket thrusters to correct for any changes in its orbit. Even though Earth's moon doesn't have a submoon now, it may in the future, according to the researchers. An artificial one, perhaps NASA's planned Lunar Gateway. The Lunar Gateway would help to establish humanity's presence in deep space, as outlined by William Gerstenmaier, Associate Administrator of Human Exploration and Operations Mission Directorate at NASA headquarters. The possibility of moons having their own moons is a fascinating one, even though we haven't found any examples yet. The majority of detected exoplanets are giant planets, at least one. Kepler-1625b may have a very large exomoon. Nonetheless, no notable moon of a moon or subsatellite is known in the solar system or beyond. There are, of course, human-launched satellites in temporary lunar orbit. The planets with the highest potential to host long-lived submoons around their current moons are Jupiter, Saturn, and Earth. Based on its orbital separation and inferred mass and size, the new exomoon candidate, Kepler-1625b-I, appears capable of hosting a large submoon. However, it is worth noting that Kepler-1625b-I has a significant orbital inclination, which may affect the stability of submoons. There have been some possible cases of submoons in natural cases. The first notable one is in Rhea, which has a possible ring system, and has led to calculations that indicated that satellites orbiting Rhea would have stable orbits. Furthermore, the suspected rings are thought to be narrow, which is something caused by shepherd moons. A shepherd moon is a small natural satellite that basically creates a gap in planetary ring material, or keeps particles within a ring contained. We find that 10-kilometer scale submoons can only survive around large moons on wide separation orbits. On top of that, tidal dissipation destabilizes the orbits of submoons around moons that are small or too close to their host planet. This is the case for most of the solar system's moons. Next up, we have Iapetus. It's been proposed that Saturn's satellite possessed a subsatellite in the past. This is one of several hypotheses that have been put forward to account for its unusual equatorial ridge. It may be that in many or even most cases, there are multiple factors that make the orbits of submoons inherently unstable. Knowing whether that is true or not may have to wait for discoveries of moons orbiting distant exoplanets. So that's why a moon can have a moon, yet we don't see many moons with submoons in their orbit. Don't forget to subscribe and to turn notifications on for more videos like this one.
Since the late 40s, humans have looked towards the stars and tried to escape to worlds beyond. But we aren't the only animals who've experienced the zero gravity of space. NASA has sent everything from monkeys, rats, dogs, and even fish into orbit. You might also be surprised to know that some of our 8-legged friends also took a trip beyond Earth's atmosphere. So, what happened when NASA sent spiders into space? Welcome to Factnominal, and in today's video, we're taking arachnophobia to the stars in What Happened When NASA Sent Spiders into Space. Golden orb weaver spiders are nature's great architects of entrapment, the original inspiration behind Marvel's Spider-Man, and arguably much better web builders. They belong to one of the oldest group of spiders, having been on this planet catching and bundling up prey to hang from their webs like gruesome trophies for over 165 million years. They form massive silken structures that are gigantic in proportion to their size, and even in the 21st century, scientists still can't replicate the waterproof material that is as elastic as nylon and 5 times as strong as steel at relative thickness. The silk is homemade, formed in their rear ends by fusing together amino acids to form a long chain of protein, before delicate valves in the spinnerets control the rate of delivery and thickness of the silk. The mental giants at NASA wanted to see if the Earth's gravity had anything to do with a spider's ability to produce such spectacularly complex webs, so decided to test out the hypothesis. 2 golden orb weaver spiders were selected for the experiment, and the legend of Esmeralda the arachnonaut and Gladys the astronid were born. The historic experiment. The very first study of arachnids in space was aboard the Skylab space station in 1973. After high school student Judith Miles proposed the experiment as part of a nationwide competition. The common cross spider was the orb-weaving species used for its ability to live 3 weeks without food or water. Arabella was the first to be let loose in the enclosure and refused to leave her cramped transport chamber. After coaxing her out, she built a small mess of web in the corner where she remained for a few days. Backup Anita was deployed next for the purpose of observing 3 fully formed webs over the course of the experiment. Sadly, she also built a substandard web which she proceeded to consume. A protocol was approved to feed them a small amount of filet mignon to provide additional nutrients and a water supply for the experiment, which proved ineffective. Back on Earth, the failed experiment highlighted an important conclusion, that spiders needed sufficient sustenance to build webs in space for any future study to take place. The official name for this scientific investigation was the Commercial Generic Bioprocessing Apparatus Science Insert 05, a huge mouthful appropriately abbreviated to CSI-05. It seeks to study how microgravity affects spiders, fruit flies, and the directional growth of plants. This was the next iteration of the popular experiment series made famous by the successful completion of the full life cycle of the brilliantly orange-colored monarch butterfly in CSI-03 back in 2009. This CSI-03 study also featured orb weavers. However, issues with their food supply and vision being obscured in the observation window limited the experiment to a mere 8 days, building up CSI-05 to be a bigger and better spidery sequel. The spiders and enclosure were transferred to the International Space Station aboard the Space Shuttle Endeavour on May 16, 2011. The module and associated equipment served to provide and maintain a consistent environment with a consistent temperature, humidity, and lighting cycle for the spiders to replicate conditions found in the natural environment here on Earth. Not only the ones in the limelight. Spiders wouldn't do too well on the rations that astronauts, and we use this term loosely, enjoy while they're up in space. Spiders eat other bugs, a resource that is notoriously absent from the controlled environment of the International Space Station. As a result, a secondary experiment was proposed that had a dual purpose. Fruit flies would be bred from larvae in zero-gravity environment to not only see the effects microgravity had on their behavior, movement, flight patterns, and reproductive cycles, but also ultimately became chow for other insects on board, predatory arachnids. Once scientists had successfully grown and studied the adult fruit flies, they would be added to the spider enclosure to act as sustenance for the primary experiment. Humans share a huge portion of their genome with fruit flies, and 75% of the disease-causing genes found in humans can actually be found in the humble fruit fly. Some of the data collected from the space flies was translated and used to help map the human genome. Something for everyone. Schools around the globe joined in on the fun as well, with over 130,000 students participating in the BioEd online program, a resource for teachers that provides a step-by-step guide on replicating the CSIO-5 experiment on Earth. Teachers help students build their own controlled habitat in the classroom for both fruit flies and their own native species of orb-weaving spider. They serve to act as a control set of data to compare the data gathered on the ISS-2. The initiative was aimed to stimulate children's curiosity and plant the seed of interest for them to pursue a career in engineering and the sciences. A great childhood memory that showed them how science could both be fun and challenging at the same time. A false start. Upon reaching their new home in space, the spiders took substantially longer to make the adjustment than the human astronaut crewmates. The first 3 days saw very chaotic and misshapen webs, often too poorly constructed to catch their fruit fly prey. Instead of erecting an effective two-dimensional web to catch their fruit fly prey, webs extended in all directions, with huge gaping holes that the fruit flies could drive a semi-truck through. They overcame this initial hurdle, however. In the second half of their first week in space, saw them adapt to the weightlessness of space and spin webs that more resemble those seen on terra firma. Over the period of a few days, the design became more complex and regular as the spiders made changes to account for the microgravity and started to successfully trap prey. The results. After the shaky first few days acclimated to space, both Esmeralda and Gladys quickly fell into the routine of erecting a new web each day, before eating it in the simulated evening to reabsorb the protein needed for next day's web. This conservation of valuable nutrients is the same behavior seen by their kind here on Earth. Golden orb weavers will typically spin and mend their webs at all times during the day. However, the two in space typically followed a stricter construction timetable. They would erect a brand new web in the early morning hours and quickly get to the task of consuming their web immediately after dark. Unlike other species who sit at the center of their webs waiting for a meal, golden orb weavers spin asymmetric webs with their waiting parlor off-center and located on the edge of the web near an anchor point. From here, the web's kill zone fans out over an 180-degree range. Oddly, in space, Esmeralda and Gladys spun symmetric webs, sitting in the center, vastly different to the control species in classroom. Typically, golden orb weavers face downwards while sitting on their webs. As gravity assists them to pounce on prey caught in the web below, the upside to building a web in space is that there is no resistance from gravity. The end result was that the attacking prey in any direction was much easier than on Earth, and in effect, the spiders became much better hunters while in space. Both Esmeralda and Gladys could move around much faster than their brethren in the classrooms back home. Though the experiment only lasted 45 days in space, the classroom studies provided the data necessary to make a detailed cross-analysis of the data to see how microgravity really affected the spiders. Silk samples sent in from around the world were compared to those made in space. Spiders in orbit used a much thinner diameter web, proving that the spiders use gravity and their relative weight as parameters for web construction and design. The other experiment. Ahead of their revisited experiment of web spinning in space, NASA also exposed spiders to a number of chemicals in 1995 as part of a study affectionately known as Spiders of the 60s. It involved administering them with therapeutic doses of caffeine, marijuana, benzodrine, and chloral hydrate. Not surprisingly, being under the influence of mind-altering substances severely hindered a spider's ability to make a symmetrical web. As the dosage increased, there was a notable decrease in the number of sides of the web a spider made. Surprisingly, caffeine produces some of the worst webs, begging the question, how healthy are those 2 cups of coffee a day? What do Scotty's transporter from Star Trek, Doctor Who's TARDIS, and the Bifrost used by Marvel's Thor all have in common? Well, they utilize wormholes in one form or another to near instantly transport people through space and across different dimensions. So, are wormholes a viable option then? Or are they just the stuff of science fiction, myth, and legend? If they are real, can we use them to expand out across the universe and through time? Or are we playing with fire? Welcome to Fact Nominal, and today, deep into the vortex in why wormholes are a big deal. Are they real? In reality, wormholes are a theoretically possible construct. However, we have gathered no evidence either confirming or denying their existence. They were first theorized in 1916, a passage through spacetime predicted by the general theory of relativity. While reviewing another physicist's solutions to the equations Albert Einstein proposed, Ludwig Flamm realized another solution was possible, a reversal of a black hole, with another opening connected by a space-time conduit. In 1935, Einstein and another physicist by the name of Nathan Rosen used the general theory of relativity to expand on Flamm's idea, proposing the existence of the Einstein-Rosen bridge. It would be a way to connect 2 different points in space-time, creating a shortcut of sorts, otherwise known as a wormhole. The idea that space-time is effectively folded, with 2 extremely distant points linked by the bridge formed by the wormhole. At this point, the whole idea is very hypothetical. Very few scientists think we will be stumbling across any wormholes anytime soon. To get a true feel for what a wormhole is, we need to brush up on our high school science classes and get better acquainted with black holes. What's a black hole? In short, a black hole is formed when a star exhausts its stored fuel required to maintain the nuclear fusion reaction at its core, effectively combining 2 hydrogen atoms to form a single helium atom. The gravitational forces required to sustain this reaction are almost immeasurable. Once the hydrogen is all used up, the star explodes into a supernova before contracting in on itself in a gravitational collapse, creating the black hole. The intense gravity required to form the star and maintain its burn effectively dooms it to a life of sucking matter and radiation into its void. They can only be tracked by the gravitational forces they exert on celestial bodies around them and cannot be seen as not even light can escape, forming a point of no return called an event horizon, effectively the mouth of a giant funnel. Okay, so then what's a wormhole? A wormhole is essentially another funnel, attached to the back of a black hole with the mouth aiming the opposite way. Having an appearance a little like an hourglass, the rear wormhole is frequently referred to as an opposite white hole. It's thought that the mouths are spheroidal in shape, with the throat spiraling with a slight wind before reaching the Einstein-Rosen bridge, linking the 2 structures together. A naturally occurring black hole, formed from a dying star, is not thought to create a wormhole by itself. For a wormhole to exist, there must be exotic matter present, a substance entirely different from regular anti- or dark matter. Exotic matter is classified as containing negative energy density and a large negative pressure, and so far has only been seen in the behavior of certain vacuum states as part of the quantum field theory. In essence, wormholes may or may not exist, and if they do, it's with the help of unnamed exotic matter, which also may or may not exist. Then there is the fact that the general theory of relativity fundamentally excludes the existence of exotic matter by its very nature. Wormholes may not only connect to different parts of the universe, but also 2 entirely different universes. It's also theorized that they could connect the same place in the universe, but in a different time. Think time machine. Can we use them? Nearby stars are an unachievable goal. It would take around 165,000 years to complete the journey to our nearest star, Alpha Centauri, traveling at approximately 17,600 miles an hour. And even then, sending word that we've reached our destination would take 4.3 years to reach the Earth. Then there's the monumental task of building a ship to last that long in space. Obviously, this is an unfathomable amount of time, a total waste of brain power to even consider it. Unless alternate technologies could get us there substantially faster, let's look at some feasible options. There are antimatter engines, which are not even theoretically possible yet, let alone viable. Then there's nuclear fusion rockets. Not only are they yet to exist, a prototype would be too large to fit on a spacecraft. Some scientists have proposed nuclear pulse propulsion, which lays small nuclear bombs behind the ship so the blast can push it along, which sounds like a super bad idea. Futurists have theorized the possibility of magnetic Bussard ramjets that suck up nearby magnetic fields to fuel the drive. Again, not even theoretically possible yet. This leaves us with only one realistic option: wormholes. The only catch is that the laws of physics would forbid any solid matter from traveling through a wormhole. It's somewhat likely that information may be able to be passed through the other side using electromagnetic radiation, but even then, it's pure speculation. Are they dangerous? The addition of regular matter contained in a human being to the exotic matter theoretically contained within a wormhole could cause it to suddenly and violently collapse, a cancellation effect that would cause a chain reaction and destabilize the entire Einstein-Rosen bridge. Traveling through a wormhole, if it even stays open following your entrance, would also be tricky, mainly because of the black hole part. You would be expected to die instantly. Well, sort of. Your reality would split into two. In one, you would be instantly incinerated, or torn apart into subatomic particles, or both. In the other reality, you would fall into the abyss of the black hole, completely unharmed infinitely. Time would have no meaning. The truth is that a black hole is a place where the laws of physics as we know them break down and cease to exist. Gravitational force can wrap the fabric of space-time itself, and in a place with this much gravity, a black hole can be twisted in on itself, burrowing a hole in the very fabric of reality. Even if there was a way to prevent the above two scenarios, there is the pesky nuisance of the extraordinarily powerful radiation you would be exposed to. Historically, humans don't do so well when exposed to a large dose of nuclear byproduct nasties. So, good or bad idea? Current technology has advanced insufficiently enough to create, enlarge, or stabilize black holes, and that means that the wormholes are completely out of the question. Even if one could be found, we would have no way of using it. Astrophysicist Eric Davies from EarthTech believes that enough to create. Bad idea? Current scenarios, there is the pesky nuisance of the extraordinarily powerful radiation you would be exposed to. Historically, humans don't do so well when exposed to a large dose of nuclear byproduct nasties. So, good or bad idea? Current technology has advanced insufficiently enough to create, enlarge, or stabilize black holes, and that means that the wormholes are completely out of the question. Even if one could be found, we would have no way of using it. Astrophysicist Eric Davies from EarthTech believes that wormholes are our best bet at achieving time travel. He thinks it's possible according to the general theory of relativity, and scientists have already sent tiny particles called muons, similar to electrons, forward in time by manipulating the gravity around them. But we are talking in the order of nanoseconds here. Davis thinks that the wormhole won't be a method for traveling indescribably long distances through the universe, but rather sending humans through what is called a closed time-like curve, otherwise known as a time machine. The problem here is that the amount of exotic matter needed to create this quantum back reaction would destroy the wormhole almost immediately after its creation. Famous astrophysicist Stephen Hawking is of the opinion that you can't have your cake and eat it too. Scientists must either ground their arguments based in either the general theory of relativity or in quantum theory, both of which are not only incomplete, but neither is able to fully encompass and explain the complexities of the universe and its physics. Before scientists can look at discovering and utilizing wormhole technology, there needs to be a reconciled set of rules, often referred to as the quantum theory of gravity. Hawking goes on to that, although a wormhole-based machine to travel through time and space is possible under general relativity, the rules of quantum mechanics expressly deny the possibility of it being used to transport any variety of matter or radiation through the portal. Scientists are hopeful, however, that in the distant future, wormhole technology could be utilized to power craft to send mankind to even our closest star, other parts of the Milky Way, and maybe even to other galaxies in the far reaches of the universe, almost instantaneously.
The last decade was an eventful one. We saw the end of the government-funded space shuttle program, the first image of a black hole, and close-up photos of Pluto, the dwarf formerly known as a planet. So far in 2020, we've had billionaires send privately funded test rockets into outer space, and scientists have sent another rover to Mars in search for signs of fossilized extraterrestrial life. So it begs the question, what does the next decade have in store for us? Welcome to Factnominal, and we're marking the celestial calendar in 10 insane space events happening in the next decade. Probing Rock, 2022. Asteroid 16 Psyche is a curious hunk of rock floating through outer space. While most asteroids are made up primarily of rock, Psyche contains an extremely high concentration of nickel and iron. In 2022, NASA plans to launch a spacecraft to probe the asteroid, which fluctuates between the orbits of Mars and Jupiter. It's suspected that Psyche is actually an exposed chunk of the core of an earlier formed planet, one which now doesn't exist and may even form part of the molten nickel-iron core of the Earth. The mission aims to study the violent collisions and other forces needed to create planets. Greedier businessmen are also looking at the possibility of mining the precious metals within the 113-kilometer asteroid, thought to be worth a staggering $10 quadrillion. Comparatively, the combination of all currency on Earth only totals to $80 trillion, give or take. A Dark Mission, 2022. The European Space Agency will be launching its Euclid mission in 2022 for the purpose of studying the theoretically assumed and until now undetectable dark energy and dark matter. Very little is known about a substance that scientists say must exist and contains 95% of all the matter in the universe. An orbiter will launch from Cape Canaveral, deploying a telescope with the Near-Infrared and Photometer, or NISP, instrument needed to assess why billions of galaxies are moving away from us at an abnormally fast rate. It's suspected that cosmic bodies traveling faster than the rate of expansion are being propelled by dark energy, the great mystery of this century. Life within our solar system, 2023. Scientists want to launch a spacecraft in 2023 to survey and assess the fourth largest of Jupiter's 79 moons, Europa. The purpose of the mission is to sample some of the ice which covers the surface of Europa, ice made from water that scientists suspect is twice as old as the water found here on Earth. If their theories are correct, Europa may even contain more than double the amount of water underneath its icy crust than is held by all the seas and oceans on our blue planet combined. In broader terms, a question needs to be answered. Can Europa sustain biological life and one day human life? Martian Moon Mission 2024. The Japan Aerospace Exploration Agency, or JAXA for short, will be launching a mission to the Martian moons of Deimos and Phobos in 2024. The main objective is to find out if the moons are residual chunks kicked out into orbit from Mars' surface after its formation or as a result of direct meteor strikes. Then again, they could just be large asteroids that were captured in its gravitational pull as they traveled close to the planet. Both moons have a decaying orbit, meaning that one day they will both crash down into the Martian surface. It's unclear which moon will meet its doom first, Deimos or Phobos, with the race neck to neck and due to be decided in about 50 million years' time, a time when human civilization will almost certainly cease to exist. First woman on the moon, 2024. It's been over 50 years since the first manned mission to the moon. We're set to return, and as a tribute to the Apollo mission that took them there, the next decade will be all about the strong women that stand beside every strong man, his sister Artemides. The new lunar program aims to allow mankind to once again step foot on the moon's surface, but for the first time in history, some of those feet will belong to a woman. NASA is developing a powerful new rocket to get us there. Attached to the top was the Orion-class spacecraft. The Gateway spaceship will act as a base of operations and house astronauts as they go back and forth to the moon. developing working technologies that will eventually be used in the first manned mission to Mars. Day turns to night, August 2nd, 2024. A total solar eclipse happens when the moon passes between the Earth and the Sun, effectively obscuring our bright golden ball for those standing in the shadow cast over our blue planet. Due to its close proximity, the moon's relative diameter is larger than the Sun, blocking all direct sunlight and turning day into night. The one happening in 2024 will be unique, with the moon's diameter being larger than usual, occurring a day after the perigee. The longest duration will be 4 minutes and 28.13 seconds near the town of Nazas in Durango, Mexico. It will also be the only total solar eclipse in the 21st century that will be totally visible in Mexico, the US, and Canada. Interestingly, a smaller partial solar eclipse happens just 177 days later. Comet 9P Tempel 1, May 26, 2024. Comet 9P Tempel 1 orbits the Sun within the asteroid belt located between the orbits of Mars and Jupiter. It last achieved perihelion, otherwise known as a close approach to the Sun, in 2016. It takes the comet roughly 5.5 years to orbit the Sun. In 2005, the Deep Impact mission sent an impactor into the comet, becoming the first spacecraft to eject material from the surface of a comet and then collect it for study. On May 26, 2024, it will pass relatively close to Jupiter, roughly half the distance from the Earth to the Sun. Coming within this proximity of the supergravitational gas giant may be the end of the comet, causing it to break apart in a fiery doom. A titanic effort, 2027. NASA will launch its Dragonfly drone spacecraft in 2026 to explore the largest of Saturn's 62 known moons, Titan. It's uncertain whether the moon could be classed as a microplanet, as it's an ocean world with a dense, hazy atmosphere with seas of liquid methane instead of water. Massive clouds in the sky can rain and even snow methane. Titan is the only other place in our solar system with a similar atmospheric pressure to Earth, composed almost entirely of nitrogen, just like ours. The Dragonfly will be exploring various locations on the moon to determine whether the conditions on Titan mimic the Earth billions of years ago, well before the formation of life. The Dragonfly mission will arrive at the planet in 2036 and will shed light on how the first organic chemical compounds formed on Earth acted as a precursor building blocks for the primordial soup, where life eventually sprung into existence. Message in a Bottle, 2029. A Message from Earth, or AMFE, is a super high-powered digital radio sent out from Earth on October 9, 2008, with the express purpose of being intercepted by an alien civilization. It was pointed in the direction of Gliese 581c, a planet mad famous for being the first super-Earth to exist in an orbit in the Goldilocks zone or habitable zone of a sun. This is a distance from the Earth star where liquid water can theoretically exist, and therefore a potential to contain organic life. It's only 20.37 light-years away in the constellation Libra within our own Milky Way galaxy. The AMFE signal is actually a time capsule containing 501 messages that were selected as a result of a competition on social networking site Bebo. Ukraine's state space agency lent their advanced RT-70 radar telescope to broadcast the message. Too close for comfort. October 13, 2029. The near-Earth asteroid Apophis will make an extremely close pass to Earth on April 13, 2029. Well, in proportion to space terms anyway. It will fly past at just 31,200 kilometers away from the surface of our planet, or 0.0002 astronomical units. To put it another way, that's just 2/10,000ths of the distance between the Earth and the Sun. A scary thought, as there's satellites in the Earth-bound geosynchronous orbit that are further away. Apophis was a cause for concern in 2004 after initial observations and calculations gave the asteroid an alarming 2.7% chance of crashing into the Earth. That's a 100-foot wide chunk of rock we're talking about. It was later found out that it would pass through a gravitational keyhole and will likely miss the Earth, though it's still on the Level 1 watch list. There is nothing more visible or recognizable in the vast night sky than the stars sparkling in the heavens above. But what do we know about stars, aside from them being pretty to look at? How big is our sun compared to other stars we found so far? Welcome to Factnominal, and today we're exploring the 10 biggest star discoveries in space. What is a star? Stars are immense, luminous balls of burning hot gas called plasma. They're held together by the gravitational force exerted on the atoms that make up its huge mass. From the perspective of Earth, they look tiny, but it's only because they're so far away. In fact, our closest star, Alpha Centauri, is 4.367 light-years or 1 trillion kilometers away. This means that light, traveling at almost 300,000 kilometers per second, would still take years to get there. To put it into perspective, a space shuttle sent out from Earth would take a little over 100 years to reach the nearest star to our own sun. And they would be there for 4.367 years before the Earth receives broadcast announcing their arrival. The energy produced by a star is emitted as light, heat, energy, and radiation as a byproduct of the nuclear fusion happening at its core. 4 hydrogen atoms are squeezed together so tightly by the incredible gravity and weight of mass that they're transformed into the 2 protons and 2 neutrons that form a helium nucleus. Stars literally exist because of the balance between 2 opposing forces: the gravity formed by their mass trying to make the star shrink versus the heat and energy released by the internal reaction trying to make it grow. How are stars formed? Clouds of gas and dust in space materialized after the Big Bang 13 billion years ago as matter began to be drawn together by gravity. These clouds are the birthplace of the stars. As the gas and particulate matter begin to get closer together, parts of the cloud shrink in size and begin to collapse, forming focal points called cores within the cloud. The gravity in the cores increases to the point where it gets so dense that nuclear fusion begins, and with the byproduct given off as heat working against its own gravity, a star is born. This process is known as stellar ignition, and the initial burst of light made by a newly formed star blows away much of the surrounding cloud particles, but not all. The remainder of the material left behind forms planets over time. How they're classified. The most logical way to sort stars is to group them based on their mass and temperature. Generally, the more mass a star has, the more intense the nuclear fusion reaction inside, hence the more heat it pumps out. The scale progresses from O through B, A, F, G, K, and M, where O-class stars exceed 30,000 degrees Celsius, and those in the M group with 3,000 degrees Celsius or less. The temperature of a star causes it to burn at a different color, similar to superheating a piece of metal. Stars range from red, orange, yellow to white, and all the way up to blue. Our own sun is a Class G yellow dwarf and sits in the range of 6,000 to 7,000 degrees Celsius. Stars are extremely variable in size. A neutron star is just 20 to 40 kilometers in diameter, where a white dwarf is roughly the size of the Earth. The largest supergiants can be more than 2 million kilometers in diameter, which is more than 1,500 times the size of our sun. How long do they live? The lifespan of a star is directly proportionate to the nuclear fusion reaction at its core. Supergiant blue stars burn through their fuel very quickly and can last just a few 100,000 years. In addition to the hydrogen to helium nuclear fusion, they produce heavy metals. Eventually, they give way and form a red supergiant, the biggest class of star in the universe. This red supergiant expands until it reaches a tipping point, causing a violent stellar explosion called a supernova, and for a brief moment emits so much light it outshines the rest of the universe. The end result can go one of 2 ways: the formation of a particulate-ejecting super-dense neutron star, or the hungry infinite gravity of a black hole. As average-sized yellow stars approach the end of their life cycle, they increase in size by up to 1,000 times, their dwindling fuel supply turning them into red giants. When there is no energy left, the star begins to lose layers and forms a complex structure called a planetary nebula. The end result is the formation of a white dwarf and extremely dense star. On the other hand, smaller red stars burn at a much slower rate and can exist for billions of years. As they die out, they form a rather uninteresting brown dwarf star. How are they measured? Measuring a star is tricky business. It's a moving goalpost, as stars have no definitive surface edge to use as a marker for the origin and termination of the measurement axis. There's no cosmic ruler that astronomers can use, so instead a star is measured by its angular size, which is a width measured in degrees. The hard part is that stars expand and contract as a result of the ebbs and flows of the nuclear fusion reaction, and as a result their brightness changes, which gives stars their notorious twinkle. At the end of the day, all you can do is average out a star's size, or calculate it based on best guesses. The term used to measure a star is a solar radius, based off the radial distance of our own yellow sun. So, let's venture through the top 10 biggest stars we've discovered so far. Number 10. KW Sagittarii, 1,460 solar radii. Sitting 7,800 light-years from Earth is KW Sagittarii, a star 1,460 times the size of our Sun. If it were the central star in our solar system, its borders would exceed the orbit of the planet Mars. Despite being much larger, it burns at a little over half the temperature of the Sun. Number 9. KY Cygni, 1,420 to 2,850 solar radii. The constellation Cygnus is 5,000 light-years from Earth, and KY Cygni is the biggest star in the cluster. Unfortunately, our field of view is blocked, so we can't visibly see it, and instead we have to calculate its size based on the electromagnetic radiation and radio waves it emits. Number 8. RW Cepheid, 1,600 solar radii. We can see the constellation Cepheus from the northern hemisphere of the Earth. It contains some whopper stars, and RW Cepheid isn't even the biggest of the bunch. It's still an impressive 1,600 solar radii, and if put in our solar system, its outer margins would extend far beyond Jupiter. Number 7. V354 Cepheid, 1,520 solar radii. At 9,000 light-years away, we have V354 Cepheid coming from a group of jumbo-sized superheated stars in the Cepheus constellation. It's the one exception to the rule, as it has become cool due to its age, meaning it could be well on its way to an explosive supernova status. Number 6. WHO G64, 1,540 solar radii. This poor WHO G64 star has had a hard life. It's actually located in a dwarf galaxy called the Large Magellanic Cloud that orbits the Milky Way. It's nearing its supernova death and has grown to a huge size, expelling enough mass and material to form between 3 and 9 of our solar systems. Number 5. V838 Monocerotis, 380 to 1,970 solar radii. V838 Monocerotis is an extremely unstable star. It pulses, expanding and contracting wildly as the reaction at its core burns out of control. As a result, its size changes each time it's measured by the Hubble Space Telescope. Number 4. Mu Cephei, 1,650 solar radii. With a luminance 38,000 times greater than that of our own Sun. It's part of a huge group of stars in the Cepheus constellation. Number 3. VV Cephei A, 1,675 solar radii. VV Cephei A is a part of an eclipsing binary star system and is quite unique. Its companion blue star is slightly smaller, but will one day eventually swell to become a red supergiant just like its counterpart. Number 2. VY Canis Majoris, 1,800 to 2,100 solar radii. The massive VY Canis Majoris was the largest known star for a very long time. If put in the center of our solar system, it would take up enough room to nearly reach Saturn. The constellation Canis Majoris contains an inexplicably large number of variable-sized twinkling stars. And finally, number 1, Stephenson 218, 2,150 solar radii. This is the biggest star we know of, Stephenson 218. It is so large that it has a volume 10 billion times bigger than our Sun. Placed in our solar system, it would engulf Saturn and almost reach Uranus.
I am excited to go to Mars this morning.
Our collective perseverance is what has gotten us to this day.
People love space, whether it's looking up at the stars on a cloud-free night or debating the existence of aliens. There's no doubt about it, space and space travel has captivated us since we first saw stars. But the adventure of space doesn't just lie in history, they're also in our future. Today, we're counting down 10 insane space discoveries to look forward to in 2021, and the top spot will blow your mind harder than a rocket ship. All of these were taken from the official NASA calendar, but they come from all around the world. Number 10. Let's start with a little hope. The United Arab Emirates mission goes into Mars orbit scheduled for February, but specific dates not yet confirmed. Emirates Mars mission, otherwise known as HOPE, is a Mars orbiter mission. It was originally launched from the Taganashima Space Center in Japan at 21:58 Universal Time on the 19th of July 2020, but its mission is far from over. HOPE will orbit Mars and study the various dynamics of the Martian atmosphere. It will also look at how the atmosphere interacts with outer space and the solar wind. The primary scientific objectives are to search for weather connection. These are the ones between the current Martian weather and the ancient climate of Mars, which might give us a look into its history. The study will look at the lost planetary mechanisms of Mars' atmosphere, which has recently been found to have once held water. It will do this by tracking the escape of hydrogen and oxygen, along with behaviors of the weather. There are 2 years of science operation planned, which are estimated to move into motion around the beginning of May 2021, but there's no official date yet. Number 9. Kicking off the year. The NASA Lunar Halo Orbiter, precursor for Lunar Gateway, scheduled for January, exact date not confirmed. The Cislunar Autonomous Positioning System Technology Operations and Navigation Equipment, otherwise known as Capstone, is a 12U CubeSat that does not need to be manned by an onboard presence. It's been specifically designed to go into one of the several halo orbits around Earth and to closely match the Moon's orbit. The primary objective of doing this are to demonstrate the ability of spacecraft to spacecraft navigation in this orbit. It also endeavors to verify the feasibility of this orbit so to gain experience for future flights. These will be able to use similar orbits. It's also a precursor to the possible Gateway lunar orbiting outpost that's been discussed. Capstone will travel for just 3 months under its own propulsion, but its findings will be immensely useful. Number 8. The Trojan isn't a horse. The launch of NASA flyby mission to multiple Trojan asteroids scheduled for October 16th. The Lucy mission is designed to make flyby observations of a total of 7 asteroids. It will be looking at 1 main belt asteroid and further 6 asteroids. They are all orbiting ahead of or behind Jupiter and are known as Trojan asteroids, a clever callback to real-life legends. Lucy is scheduled to launch on October 16, 2021. Number 7. Finding ice might mean finding life. The launch of NASA CubeSat mission to find lunar water ice. The Lunar Flashlight is a modified 6U CubeSat mission and not the only CubeSat on our list. It's designed to go into polar orbit around the Moon. From there, its main objective will be to search for water in the shadowed polar regions where there's a reasonable belief that it might be. Scientists want to find locations on the lunar surface where water in the form of ice is present at concentrations that might suggest supporting life. The spacecraft will make observations from an elliptical near rectilinear polar orbit. These will be between altitudes of 12.6 and 52.4 kilometers. The mission is going to be 2 months long. Number 6. Scouting for trouble. The launch of a NASA CubeSat mission to fly by a near-Earth asteroid at some point towards the end of the year. The Near-Earth Asteroid Scout, otherwise known as NEA Scout, is one that sounds much more critical than its launch date might suggest. The mission will be using a 6U CubeSat and will involve a solar sail to fly by and then return images of a near-Earth asteroid 1991 VG. The primary objectives of this mission is to make a minimum of 1 slow, close flyby so it can return the images. Scientists can then observe the asteroid's position in space, shape, rotational properties, spectral class, local dust and debris field, regional morphology, and regolith properties. The spacecraft is scheduled to be a ride-on mission on the Archimedes 1, which will launch towards the end of 2021. Number 5. Red Planet Roving. NASA rover and rotorcraft land on Jezero Crater on Mars, scheduled for February 18th. The Mars mission involves landing a large roving vehicle called Perseverance on the surface of Mars. From there, it's going to conduct mobile studies which will focus on the surface environment. It's going to concentrate on habitability, past life, and sample collection for future missions. The spacecraft itself has 3 major components. There are the entry systems, the descent and landing system, and the rover itself. The primary science objectives of Mars are to identify past environments to see if they were capable of supporting microbial life, seeking signs of possible living things. 4. NASA announcements. Not as technical, but still exciting. More than 12,000 people applied to be an astronaut between March 2nd and March 31st of 2020, and those applications are now in discussion. Next year, we'll get to see who's in the next generation of space adventure. Number 3. Probing Venus. The Parker Solar Probe is designed to orbit the Sun, which involves some seriously high-end technologies. It's going to be making several close approaches so that it can attempt to trace the flow of energy and study the heating of the solar corona. nothing to do with the virus. It's also going to explore the acceleration of solar winds. The Parker Solar Probe was already launched on the 12th of August 2018 and has done 4 flybys of Venus already as it withstands the heat and sends back data. According to NASA's site, its main objectives are listed as to trace the flow of energy that heats and accelerates the solar corona, to determine the structure and dynamics of the plasma and magnetic fields at the source of the solar wind, and to explore mechanisms that accelerate and transport energetic particles. Number 2. Reaching Mars. The Chinese orbiter, lander, and rover mission will reach Mars sometime in February. The Chinese orbiter mission will make a 7-month trip to Mars. It will be arriving and going into polar orbit on February 2021, but no specific day is set. The orbiter will use high-resolution cameras to reach for the best landing site for the lander and its accompanying rover. They will separate from the orbiter and each other and make a landing somewhere in the Utopia Planitia region. Number 1. There's nothing cooler than blowing things up. The Double Asteroid Redirection Test, or DART mission, scheduled for July 22nd. As we said, there's nothing cooler than blowing things up, so this one takes the top spot. The Double Asteroid Redirection Test, otherwise known as the DART mission, is designed to evaluate the kinetic impact technique. This will be valuable in planetary protection. It will be done by striking an asteroid with a spacecraft at high velocity, which is relative to its size, and then observing the resulting change in orbit. NASA says that its primary objective is to assess kinetic impact as a method. This will be used for redirection of any future asteroids which are found to be on a trajectory to impact Earth and which might be dangerous. The test involves flying the DART spacecraft into the smaller of 2 asteroids, both of which are co-orbiting the Earth in a binary pair. They will be using Earth-based observations both before and after the impact to study the effects on the orbit. If you like this video, please don't forget to leave us a like to support the channel so that we can continue to bring you more great content. Your support means the world to us. We see every subscriber as part of our crew. So be sure to like, comment, and ring the notification bell if you want to fly forward to spectacular, space-tacular content and more. Space is full of weird and wonderful things, and not all of them involving little green men from Mars. Sometimes the most bizarre things astronauts find in space have perfectly logical explanations, but that doesn't make them any less fascinating. Want to take a look at the weird and wonderful world of space discovery? Welcome to Factnominal, and today we're on a mission for treasure in 10 bizarre things astronauts found in space. Number 10. The Orange Space Station. The first Italian to venture into space was an Air Force pilot named Samantha Cristoforetti, and somewhat stereotypically was also the first astronaut to successfully brew an espresso coffee in zero gravity. While on board the Soyuz TMA-15M shuttle en route to the International Space Station, she reported something strange. The ISS is mostly white with dull silvery gray accents. Imagine her surprise then when it blazed a bright burnished orange as she made her approach. She wrote on her blog, the enormous solar panels were inundated with a blaze of orange light, vivid, warm, almost alien. Though this is a rare phenomenon, it's not unheard of. When the sun hits the 16 long, thin panels that extend out from the ISS like fingers at just the right angle, it produces a halo of orange light. 9. Late bloomer. It turns out that spending time in space, and in particular living in zero gravity, has some surprising side effects. One unusual fact is that on average, astronauts that spend 6 months in orbit report a 3% increase in height after completing their return to Earth physical examination. This increase is caused by the vertebral bodies increasing distance away from each other as the cartilaginous discs are not becoming compressed by a downward acting gravitational force. It's the same concept as humans generally being taller in the morning than in the evening. In January 2018, Japanese astronaut Norishige Kanai tweeted that he had gained a whopping 3.5 inches during his time aboard the ISS, breaking all records. That's a gain of over 5% and almost double that normally seen. Number 8. Alien bugs. Russian cosmonaut Anton Skarpalov made an extraordinary claim. It was so controversial that NASA remained tight-lipped and refused to make an official comment. Skarpalov told Russian news agency TASS in an interview that bacteria he discovered on the outside surface of the ISS was of extraterrestrial origin, and there is only one explanation. They settled on the surface after coming into contact with the ISS in space. He quickly went on to explain that the bacteria pose no danger and are common on Earth, but how they got there and the fact that they could live in the void of space is one that's yet to be explained. Number 7. To twin or not to twin? There are two American brothers that share not only a special bond, but genetic material as well. Mark and Scott Kelly are identical twins. They were both captains in the U.S. Navy and both spent time on the International Space Station. NASA decided to perform a curious experiment, analyzing DNA samples from the twin brothers while one was in space and the other had his feet planted firmly on the Earth. What they found was that over a 340-day period in 2016, Scott's DNA changed by a surprising 7%. Technically, the two are no longer considered identical twins. DNA is made up of 98.5% junk DNA, which has nothing to do with our gene expression. The changes didn't affect physical characteristics, with NASA continuing their research into the how and why. 6. Was it space junk? Christopher Cassidy is a U.S. Navy SEAL, a man proven to remain calm under extreme stress. He was the 500th astronaut in space and has completed several missions to the International Space Station to perform critical repairs over hours spent working in the void of space. After coming back from one of these spacewalks, Cassidy made a report to Mission Control that he saw an unidentified flying object make its way past the ISS as he looked out of the viewing port. NASA was quick to clarify that it was most likely an antenna cover, as they received word from Russian Flight Control that the Zvezda service module had shed part of its external shielding. Still, Cassidy remains convinced that what he saw was entirely different to the space junk NASA claims was in the area at the time. Number 5. Another crazy side effect of an extended stay in zero-G is that you arrive back on Earth looking substantially younger than when you left. And no, it's not some cosmic time warp, it's just physics and human physiology at work. Weightlessness causes body fluids to move toward the head and pool there. On Earth, gravity assists circulation in draining these fluids, but of course, there's no gravity in space. The upside is that facial skin looks fuller, wrinkles are filled in, and any sagging skin retracts back into something better resembling how it did during youth. The downsides are that this blood and spinal fluid that pools in the head causes astronauts to experience unbearable migraines. But funny enough, the remedy is a simple one: relieving your bladder. Number 4. Whistle while you work. The final reconnaissance mission to the moon was Apollo 10, before Apollo 9 took Armstrong and company to be the first men to walk on the moon. It was this reconnaissance mission that was responsible to orbiting and testing the launch of the lunar module. A bizarre phenomenon was reported by the crew of Apollo 10 in what was described as space music. As their spacecraft orbited around into the shadow of the dark side of the moon, an area, by the way, that's out of radio contact due to the eclipsing area of the moon, the trio heard a haunting melody in their helmet audio. It sounded exactly like someone whistling, with a note and chord progression indicating it was not mere interference. It's been heard on other missions, and to this day, there is no rational explanation for what causes it. 3. If you don't use it, you lose it. To top off the list of weird things to happen to astronauts in space, these brave souls experience shrinking legs. The muscles in the hips, thighs, and calves wither away and atrophy, a process that begins almost immediately when not in the presence of gravity. On Earth, leg muscles are tasked with carrying around our immense bulk as we walk, run, and move around, working against gravity to hold us upright. In space, astronauts float and don't use their legs much. Even the bones decrease in density and become thin and weak. It's a major reason why time spent in space is usually limited to 6 months at a time. Even though they employ a brutal exercise regime while in orbit, astronauts still experience immense pain upon returning to Earth as their muscles get used to working again and bones gradually build up tolerance to the resistance. Number 2. Cosmic fireflies. John Glenn is one of the most well-known astronauts, and he was the first U.S. citizen to orbit the Earth. During his landmark 5-hour flight in 1962 aboard the Friendship 7, he orbited the Earth 3 times before splashing down safely in the Atlantic. During this mission, however, he reported seeing a peculiar sight out of the viewing port of his ship. He described tiny stars, unidentified speckles of light floating around the outside of the craft. NASA Mission Control were worried that Glenn was hallucinating and that he was experiencing a hypoxic episode or even a minor stroke. Worse yet, that something was wrong with the spaceship. Later that year, the phenomenon was reported again, and further investigation uncovered the space fireflies as harmless droplets of condensation on the outside of the spacecraft. Finally, number 1, space soda. James McDivitt and Ed White flew aboard the Gemini 4 mission, where they made history by orbiting the Earth 66 times over the span of 4 days in 1965. In 1999, McDivitt recounted a chilling experience as part of the NASA Oral History Project. He recalled that he saw something outside the spacecraft. It had a geometrical shape similar to a beer or soda pop can, with a long, thin object like a pencil poking out the top. NASA has offered several explanations, maybe a discarded retro rocket or the sun's reflection in the glass. He maintains that he photographed the UFO, however the mission images NASA provided for his review were not the ones he took. Most planets outside of our solar system are boring and unremarkable. If they had a favorite color, it'd probably be beige. Whether made from desolate rock or giant balls of gas, they're rarely interesting, save for a select few. So what are some of the strangest planets we've discovered so far? Welcome to Factnominal, and in today's video, we're dusting off our galactic passports and checking out 10 of the strangest planet discoveries. Number 10. Tres 2b, population bloodsuckers. This place may very well be a vampire's paradise. It's covered in a blanket of perpetual night. It's 1.5 times the size of Jupiter, with a surface that absorbs light better than charcoal and is blisteringly hot. If hell was an actual place, this would be it. Even on the ex-planet, now dwarf planet, Pluto, we would have enough light to be able to see around us on its daytime surface. But this planet is the darkest celestial body we've come across in centuries of surveying the cosmos, reflecting just 1% of the light that hits the surface, absorbing the rest. A sinister dark red glow is emanated from a smoldering atmosphere with air temperatures as hot as molten lava. It gives the dark planet an ominous glow and a look of pure evil and insanity. 9. Gliese 436b, best of both worlds. When you picture an ice cube, the image of a cold beverage with condensation on the glass comes to mind. The last thing you would think of is ice that's over 5 times hotter than boiling water. Well, on Gliese 436b, the rules of thermodynamics still apply, but in a super weird way. It has a molten core made of a liquid rock and metal, much like Earth, covered by a thick layer of water wrapped up in a nice bow made of hydrogen. Seems normal so far, until you learn that the ice burns at close to 1,000 degrees Fahrenheit. Solid water forms on Earth as the temperature drops, but here extreme pressure transforms water into ice the same way carbon is made into diamonds. It's the equivalent of burning your feet walking across a bed of ice cubes instead of hot coals. Number 8. WASP 12b, parasitic victim. WASP 12b is a doomed planet, no doubt about it. Think of it like a hotter version of Jupiter, only drawn in so close by its star's gravity that a solar year of orbit takes just 1.1 Earth days. But the super short year isn't the reason that this planet has a destined date with a gloomy fate. The star's scorching heat and powerful ionizing radiation are slowly breaking it apart. Then, to make things worse, the incredible gravity is pulling the contents of the planet into the nuclear fusion reaction at the star's core. This slow death makes WASP 12b look like an egg, as broken down gas is sucked up to a point just like a huge cosmic cone. The poor gas giant is helpless and cannot escape its cannibalistic body, being slowly sucked dry over the next 10 million years. Number 7. OGLE 2005 BLG 390LB, cold-hearted. Does the surface of a planet get colder the longer its name is? In this case, the answer is yes, as low as -370 degrees Fahrenheit. Its star is a tiny red dwarf whose light and heat barely touch the surface of the planet, leaving it only a smidgen warmer than absolute zero. The ice here never thaws, stuck in an eternal winter as a barren rock incapable of sustaining life. It's hard to imagine that only a decade ago this was the most Earth-like planet, even though it sits well outside the habitable Goldilocks orbital range. Number 6. HD 189733b, forecast, chance of rain. By all appearances, this lonely exoplanet looks like a utopia. There are no other planets in this single-star, single-planet system, and this one looks the part. It appears like a glowing azure orb, with swirling clouds pushing their way through its atmosphere. A betting man would stake his whole house on the wager that the surface has liquid water, and it would be a great candidate for a second Earth. The same man would be sleeping on a piece of cardboard under a bridge tonight. Closer inspection tells a wildly different story. The atmosphere is actually made up of hard silicate particles. In other words, it rains tiny shards of glass. And it gets better. Winds on this little blue sphere reach speeds of up to 5,400 miles per hour, or over 20 times that on Earth, ripping you apart into a fine red mist. Number 5. Dimidium. Doesn't do things by halves. The name Dimidium comes from the Latin word for half, as the planet's mass is roughly half that of Jupiter. It was the first exoplanet discovered that orbits a main sequence star. Traces of water have been found on its surface, but that's where the similarities to Earth start and end. It's tidally locked to its star, meaning the same side gets bombarded with all the solar radiation and never gets the reprieve of night. The hot side temperatures can soar, with 1,800-degree Fahrenheit winds blowing over it at 600 miles per hour. Over on the cold side, vaporized iron forms clouds that rain down ferrous metal. In other words, it hails metal. Number 4. Osiris. Come at me, bro. Named after the Egyptian god of the underworld, Osiris is a gas planet that loves first place. It was the first to be discovered via the transit method, the first planet detected in more than one manner, the first discovered with an atmosphere, the first to have its atmosphere studied in detail, the first to contain both hydrogen and oxygen, and way too many others to list. What a mouthful. Surprisingly, its atmosphere comprises of oxygen, despite being 8 times closer to the Sun than the closest planet to our Sun, Mercury. A solar year lasts just 3.3 Earth days as this ball of oxidizing, burning hot gas is bombarded by solar activity. The cosmic wind is so fierce that parts of the atmospheric gas are ripped off at 15,550 miles per hour. Carbon and oxygen follow the planet around its short orbit like a tail on a comet, hanging on for dear life courtesy of the planet's gravitational force. Number 3. Korot XO3b. Time to go on a diet. Imagine a planet the same size as Jupiter, but 20 times as dense. The gravity in such a place is 50 times stronger than that here on Earth. To give you a mental picture, stepping foot on this planet would turn you into an instant pancake, courtesy of the absolutely insane force pulling you down towards the planet's core. It's a cheeky entry, as scientists aren't exactly sure whether to classify this as an exoplanet or a failed star. It's a mystery how either a star or a planet could form so densely while being so close to a huge superdense star sitting at the center of its system. Number 2. 55 Cancri e. Two-faced. Mercury is the closest planet to our Sun. It's a hot little ball of rock, but nothing compared to 55 Cancri e. The planet has zero rotation around its x-axis, but instead spins sideways. It's in such close proximity to its star that it gets no day, no night, and technically shouldn't be able to exist. The backside is shaded, dark, and has not seen a ray of light for millions of years. The front half, on the other hand, is the complete opposite. It spent eons absorbing the intense light, brutal ultraviolet rays, and ionizing gamma and X-rays spewed out by its solar neighbor. The net result is one half of the planet is a sea of molten rock and rivers of lava, while the other is a cold desert. Number 1. Kepler 7b. Getting hot in here. Blue stars burn hot, and when they're at the end of their lives, they explode and expand rapidly outwards, forming a red giant. During this transformation, nearby objects are destroyed in the blast. Not the case for Kepler 70b. The red giant consumed the planet, but somehow it still remains intact. What's left is arguably the hottest planet we've discovered so far. A cranking hot ball of inert rock that's held together with cosmic duct tape and sheer force of will. The surface temperature is hotter than our Sun. That's over 12,000 degrees Fahrenheit. Though it survived this long in the belly of the beast, it's slowly being dissolved in the digestive juices of the dying star and will likely be eroded away to nothing well before the inevitable supernova blows it to kingdom come. Space is extremely intriguing, and some theories of the things that happen there make us wonder more about it every day. Number 10. What was there before the Big Bang? We all know that things came to be after the Big Bang, but what was there before the Big Bang? It's believed that there was an initial singularity before anything else. This is a gravitational singularity predicted by general relativity to have existed before the Big Bang and thought to have contained all the energy and space-time of the universe. The initial singularity possessed seemingly infinite density, thought to have contained all of the mass and space-time of the universe before quantum fluctuations caused it to rapidly expand in the Big Bang and subsequent inflation, creating the present-day universe. Number 9. What happens when you fall into a black hole? With black holes being one of the most intriguing astronomical objects in the universe, it's no surprise that some people have wondered countless times what would happen if you fell into one. To fully appreciate what's a black hole, we need to first understand the properties of one. A black hole is a place where gravity is so strong that nothing else can escape. Black holes are named as such because they can't reflect nor emit light, and they're only visible when they're feeding on other stars or gas clouds that come into their event horizons, their main boundary. Beyond the event horizon lies a truly minuscule point called a singularity, where gravity is so intense that it infinitely curves space-time itself. This is where the laws of physics, as you know them, break down, meaning all theories of what lies beyond are just speculation. If you were free-floating in space near a stellar mass black hole that wasn't feeding on anything, your only hint that it exists might be the gravitational magnification or lensing effect it would have on background stars. But as you flew closer to this strange spot, you'd be stretched in some directions and squished in others, a process that scientists call spaghettification. This is because the black hole's gravity compresses your body horizontally while pulling the planes happy in the vertical direction. If you jumped into the black hole feet first, the gravitational force on your toes would be much stronger than that pull on your head. Meanwhile, if you were to plunge into a supermassive black hole, things would be considerably less scary. While it might still result in a horrible death, you might make it all the way through the event horizon and manage to start falling inside the singularity while you're still alive. You'll die either way, but at least things here will be a little less painful. Number 8. The Earth will become like Venus. Both Earth and Venus are very similar planets. They have very similar cellular mass and composition. So the main difference is that Earth sustains life, and Venus is essentially a galactic wasteland because it's mostly composed of carbon dioxide. However, climate change isn't the only thing that might affect Earth becoming like Venus. As the sun becomes 10% hotter around 1 billion years from now, the surface temperature of Earth will reach 47 degrees Celsius, prompting the temperature of Earth to increase rapidly and its oceans to boil away until it becomes a greenhouse plant. A greenhouse plant, like Venus, isn't exactly the nicest place to live in the universe. Venus's atmosphere is almost entirely carbon dioxide and chokingly thick, with an atmospheric pressure at the surface 90 times that of Earth. It's the equivalent pressure of a mile beneath our Milky Way. It's so thick that you almost have to swim through it just to move around. And on top of this are clouds that are literally made of sulfuric acid. Number 7. White holes. We all know about the existence of black holes, but did you know that their distant cousins, the white holes, also exist? What do you think black holes will do? White holes will literally blow you away. Instead of absorbing matter, white holes spew out. To a spaceship through water from afar, a white hole looks exactly like a black hole. It might spin. A ring of dust and gas could gather around the event horizon. But instead of absorbing things, they're belching matter out. Physicists describe a white hole as a black hole's time reversal. A video of a black hole played backwards, much as a bouncing ball, is the time reversal of a falling ball. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission, space-time's most exclusive club. Number 6. Big Rip. All good things must come to an end, and it seems like the universe is one of these. This is something established by the Big Rip, in which scientists have theorized that the universe may end up expanding so much that it will eventually rip itself to pieces. Solar systems, planets, asteroid belts, and even whole galaxies will be torn apart. Of course, that's something that will happen several million years from now, so it's not like we're going to be here when it does. But when it does, you can bet that things will not be pretty for humans. Number 5. The Drake equation. The Drake equation is a formula that's been used to estimate the number of active extraterrestrial civilizations in the Milky Way galaxy. How many alien societies exist and are detectable? This famous formula gives us an idea. The Drake equation, it was the agenda for a The terms are defined as follows. N, the number of civilizations in the Milky Way galaxy whose electromagnetic emissions are detectable. L, the rate of formation of stars suitable for the development of intelligent life, number per year. F sub P, the fraction of those stars with planetary systems. N sub P, the number of planets per solar system with an environment suitable for life. F sub L, the fraction of suitable planets on which life actually appears. F sub I, the fraction of life-bearing planets from which intelligent life emerges. F sub C, the fraction of civilizations that develop a technology that produces detectable signs of their existence. And L, the average length of time such civilizations produce such signs per year. Number 4, time is running out. Some scientists theorize that distant celestial bodies don't seem the way they look because we're actually looking back in time to see them. That means that celestial bodies are moving faster in the past than they are now because time is slowing down. When we don't know how much it's slowing down, we know that it might slow down to a stop if things are left as they are. Number 3, hit rate opening speed. Did you know that the first signal broadcast long enough to pass through Earth's atmosphere was hit rate opening speed to the 1936 Olympics in Berlin? That means that soon they were to find Earth. That's probably one of the first things they'll mention to us when we communicate with them. It's probably the first sound they heard from humans. Number 2, the Fermi paradox. The Fermi paradox, named after Enrico Fermi, establishes that there's a contradiction between the lack of evidence for extraterrestrial civilization and very high estimates of their probability, such as the Drake equation that we just saw. Even Maya has to simply exist in one form or another, but if that's the case, then where are the aliens? The Fermi paradox establishes that it's much harder for life to exist than we originally thought, or that more life has actually existed and been destroyed over time. And number 1, the universe is a computer simulation. If you've watched The Matrix, then put your tinfoil hats on, because the universe might just be like the movie depicts it. The simulation hypothesis, or simulation theory, is the proposal that all of reality, including the Earth and the rest of the universe, could in fact be an artificial simulation, such as a computer simulation. Moderator Neil deGrasse Tyson, director of the museum's Hayden Planetarium, put the odds at 50-50 that our entire existence is a program on someone else's hard drive. He noted the gap between human and chimpanzee intelligence, despite the fact that we share more than 98% of our DNA. Somewhere out there, we have beings whose intelligence is that much greater than our own.
Silent, I will creep, gliding through the depths, gliding to your death. Upon the shores I rise, hold my flippers to the sky. I am more than a fish, I am From the coast of West Fall to From the coast of West Fall to From the coast of West, fall to in our sunken grave. Feel the deadly pin. My nets drag you in. Blood-stained sand and gore. Law that's left upon the shore. I am more than a fish. I am more than a man. Death will rise from the tide. Oh yeah, I am Murloc. I am king of the sea. But I'm not Aquaman. Death will rise, hear our cry. I am Murloc. Empty eyes, never blinking, armored and scaled, but never sinking. Puzzle jumper, the coaster runner, call me the Tide Hunter. Raise your flippers to the sky. I am more than a fish. I am more than a man. Death will rise from the tide. I am Murloc. I am king of the sea. Not a queen like Aquaman. Death will rise, hear our cry. I am Murloc. I am death. From the coast of West Fall to Black Feather Deep, silent I hunt show, silent I will creep, gliding through the depths, gliding to your death, upon the shores I rise, hold my flippers to the sky. I am more than a fish. I am more than a man. Death will rise from the tide. I am Murloc. I am king of the sea. But I'm not Aquaman. Death will rise, hear our cry. I am Murloc. Hunter of the tide, lie, will let your life born, you fallen brave, sleep in our sunken grave. Feel the deadly pin, my nets drag you in, blood-stained sand and gore, law that's left upon the shore. I am more than a fish. I am more than a man. Death will rise from the tide. Oh yeah, I am Murloc. I am king of the sea.
death.
From the coast of West Fall to Black Melody, silent I hunt show, silent I will creep, gliding through the depths, gliding to your death, upon the shores I rise, hold my flippers to the sky. I am more than a fish. I am more than a man. Death will rise from the tide. I am Murloc. I am king of the sea. But I'm not Aquaman. Death will rise. Hear our cry. I am Murloc. Hunter of the tide, lie, will let your life born, you fallen brave, sleep in our sunken grave. Feel the deadly pin, my nets drag you in, blood-stained sand and gore, law that's left upon the shore. I am
you've probably seen something like this. These devices are normally responsible for somehow sensing and correcting errors, and usually are able to do so automatically, although generally they do come in different shapes and sizes and generally control different functions of either mechanical or electrical activity. But in case of Ingenuity, this little device right here is the servo that created the anomaly that basically shut down the entire system, with the data from the helicopter suggesting that the servo was oscillating or basically moving around by approximately 1 degree, which was completely unexpected by the system, and so the entire flight was shut down. And on top of this, at this particular moment, Mars is actually right behind the Sun, and because of this, it's sort of impossible for the mission to communicate with the probe and to receive any more details or to try to conduct other tests. They'll have to wait until mid-October before they can resume these tests. Nevertheless, they do have some theories on what's probably happening here. The first theory is that, well, maybe the things have just become too old. These servers are just no longer attached as solid as they used to be attached, and so they're wiggling a lot more. And basically because the mission has already sort of been extended way more than originally planned. And for those of you who have used drones before, you know that sometimes the actual blades stop working, for one reason or another. And so this is definitely something that could potentially happen here as well. The other explanation is actually maybe because of the high-speed spin test. Maybe because of the speed involved here, instead of the resonance on the entire helicopter, it seemed to have created some kind of a unique oscillation in the servos themselves. And so one way of possibly testing this is obviously by spinning the blades slower. And so if the oscillations disappear at slower rotations of the blades, well, this just means that it's going to be impossible for the helicopter to fly in the future, at least using the high speed of rotation. And because the atmospheric pressure on Mars is not going to be getting denser for the next year or so, it means that the mission is probably going to be finished. And so at least for now, during the Martian conjunction, when Mars is behind the Sun, the only thing that's going to be happening is the general communication between Perseverance and Ingenuity as they sort of send the signals to each other in order to make sure that they both stay alive. But in mid-October, we'll finally get signals back from Perseverance, and we'll finally be able to see if the mission is still a go, or if Ingenuity is going to have to retire simply because it's unable to fly anymore. Which I guess would be kind of ironic because it had its 13th flight. Unlucky 13, I guess, which I guess would be kind of sad, but the mission has been a dramatic success, with Ingenuity outperforming any initial expectations, with this failure also teaching us a little bit more about why things don't always work on Mars, or how things can go wrong for some of the future missions. And in one of the previous videos that you can find somewhere right there, I've actually mentioned this mission right here that's probably going to be launching to Mars in the next few years, assuming of course everything works out as planned. And so for now, I guess that's all we know. The mission had an anomaly. The anomaly is most likely caused by either the parts getting a little bit too old or possibly because the blades were spinning too fast, but we're not going to know if the mission is finally finished or if it's going to be continuing until sometime in late October. Well, until then, check out all the relevant details and links, including the blog posts from the scientists behind this mission in the description below. And in the next few weeks, we'll definitely be talking more about the mission and about the resolutions or solutions to some of these problems. Until then, thank you for watching, subscribe if you still haven't, share this with someone who loves more about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel Patreon by joining channel membership or by buying the wonderful person t-shirt that happens to have the Ingenuity as its main logo. Either way, stay wonderful.